Welcome back to part 3 of chapter 14. In this section we're going to look at the third way that we can solve for exponents and find out what the order of a reaction is, and that is with the integrated rate law. And the integrated rate law is where we're going to graph information to determine what that is. If you've had calculus, you can do an integration, and this should actually remind you of some of the things like the first the first integration, the second integration of a curve, and it kind of goes along with that. So if you have a reaction of A going to products, the rate law depends on the concentration of A. We've said that. If you apply calculus to integrate the rate law, it gives you another equation, and it shows the relationship between the concentration of A and the time of the reaction. And this is called the integrated rate law. If you plot the data in several different ways, you can actually give us the reaction order without even doing the calculus, so you don't have to do the integrations. For example, if you graph the concentration of A by time and you get a straight line, that means that it was a zero order reaction. So if you get a straight line, so basically your slope is -1. Your y-intercept will be at your initial concentration of A. Then that will be a zero order. So if you graph just the concentration by time and you get a straight line, then that's going to tell you that's a zero order. If you graph the natural log of the concentration of A by time, you also get a -k. If that's a straight line, then that's a first order. If you graph the reciprocal of A, so 1 over A, concentration in molarity, and you get a straight line, that's a second order. So to just summarize them, if you have the data, which you normally do, you can put that in a graph, and you can graph that. If it's a zero order, you're going to get a straight line with just the concentration versus time. If it's a first order, you're going to get a straight line if you graph the natural log of A per time. And if it's second order, then to get a straight line, and this time it'll have a positive slope, then you'll have the reciprocal of the concentration of A per time. And so I'm just going to make a note here too. Half-life is a type of rate, okay? It's a rate of decay usually. We don't do it in this chapter because we're going to do it in the nuclear chapter. So I'm saving that for the very last chapter, which is chapter 20. So don't despair, you will be able to do a half-life expression, okay? But for now, this is our integrated rate law where we can graph information and we can see. So basically this is the same experiment, except what I did was I have the concentration of C2H5Br, and I am degrading that to C2H4 and hydrobromic acid. And I'm taking concentration readings at minute intervals, okay? So it starts at 1 and it goes down to 0.37 after 5 minutes. Then I take that data and I do the natural log of each one of these numbers, and I put that in my chart. And then I take that original and I take the reciprocal of it and I put that series of numbers in there. So this is all the same data from the same experiment. I'm just putting the time versus concentration, time versus natural log of concentration, and time versus the reciprocal of the concentration. And then I can graph that and plot that with the concentration of the C2H5Br on the y-axis versus time on the x-axis. And then I'm going to plot it 3 ways. Okay, so I plot it with just the regular concentration. Okay, and when I look at this, I mean, it's kind of straight, but it's not really. It's a curve. I look at the second order where I did the reciprocal, and it's really not a straight line. The one that's a straight line here is the plot of the natural log. And you just have to know that if it's the natural log of the concentration versus time that's straight, it's a first order. If this one had been a straight line, it would be second order. If this one had been a straight line, it would have been zero order. So all I did was I plotted this data 3 different ways, and then I just have to look and see which one has the linear graph. So from this material, this is a first order with respect to C2H5Br. Pretty easy, huh? And that's it for part 3.